Assalamu alaikum, dear friends. Welcome to the lecture of the nuclear physics. In this lecture, we will discuss about some nuclear properties, and then we will discuss use these properties into the further study for the nuclear properties and nuclear forces. So the first, we are interested primarily in the properties as the specific nuclear species rather than as a part of the atom. We call these particles nuclei. What are the properties which are associated, and what are the terminology which are used for the basic introduction of the nucleus? So the very thing is nuclei are made of the proton and neutron. The number of proton in the nucleus is called atomic number. Mean we have proton and neutron in the nucleus. So the total number of proton in the nucleus is called atomic number, and it is represented by Z. And the total number of proton plus neutron, which is called mass number, and it will be represented by A. Z is the number of proton and N is the number of neutron. So the total number, their sum will be equal to A, which is the mass number. Neutron and proton, when considered collectively, are called nucleons. So on the whole, we use the word nucleons for the whole when proton and neutron are collectively to be mean. And then the next term is isotopes. Isotopes is the some Greek word means iso means same, and topes means place. These are those atoms which have those elements which have same place in periodic tables. And why they are same place in periodic tables? Because in periodic table we have arranged the elements on the basis of their atomic number rather than their atomic mass. And in isotopes we have the same number. Isotopes are those atoms which have same atomic number, and different mass number, So if the mass number is different, it means then in periodic table they will not be. If we arrange them in on the basis of the mass number, then they will be have different mass number and different place. But we have arranged all the elements in periodic table on the basis of atomic number, and atomic number for the isotopes is the same. Isotopes are those elements which have same atomic number but different mass number. And organizing the nucleides, the neutral atom of all isotope of elements with the same mass number have the same number of electron and the same chemical properties, and they fit into the same box in the periodic tables, and it means they takes one place. The isotopes, all the isotopes have the one place in the periodic tables, means for the particular element. For example, hydrogen has three isotopes, so all isotopes are placed are in the one atom, in the place of one atom. Okay, and next is and the next term is isobars. What is isobars? Bar is the means line. Iso means same. So isobars are those atoms which have same mass number, mean same mass, no same mass number, but different atomic number. So isobars are those atoms elements which have same mass number and different atomic number. So you can see these elements: lead, then titaniums, then mercury, and then iron and platinum. These all have same mass number. Means these all have same mass number, but with different atomic number. So these elements are to be called isobars. Okay. The next term is the nuclear radii. How to find the radius of the nucleus? The very first thing is we used the units femtometer, which is also called Fermi, and is equal to 10 power minus 15 meter. This unit will be used to describe the unit to describe the radius of a nucleus. The two names after the same observation: one femtometer is equal to 1 Fermi is equal to 1 FM 10 power minus 15 meter. If we want to find the radius of a nucleus, we can learn about the size and the structure of nucleus by bombarding them with high energy. Means we have to bombard them high energy beams like alpha particle to the nucleus, and then we can observe the range, the distance of the nearest approach, the distance of the nearest approach between this alpha particle and this nucleus. This when this alpha particle will come close to this nucleus, this will deflect them into path either upward or downward or backward. So we can find the minimum distance, from the minimum distance of approach, the size of the nucleus, and hence the radius. So the electron must be energetic beam. Means those, if we have to bombard, the bombardment particles or the projectile particle should have at least 200 mega electron volt energy to be have de Broglie wavelengths that are smaller than nuclear structure are to be probed. Means those particles should be used which have 200 mega electron energy to probe or come close to the nucleus. Then the nucleus, like the atom, is not a solid object with a well-defined surface. Furthermore, although most nuclei are spherical, some are notably ellipsoid. Nevertheless, electron scattering experiment, means from the electron scattering experiment, we have derived expression to find the radius of the nucleus, which is equal to R naught a power 1 over 3, in which R naught is constant, which is 1.2 Fermi. Mean R naught, we will use the following formula for finding the radius of a nucleus. R is equal to R naught a power 1 over 3. This formula is derived from the nuclear electron scattering experiment, and we have derived the following formula for this experiment. R naught is constant, which is equal to 1.2 FM, and A is the mass number for particular atoms, and but this formula is not valid for halonuclide, which are neutron rich nuclei that were first proposed in the laboratory in 1998. These nuclei are larger than predicted because some of the neutrons form a halo around a spherical core of the proton, and the rest of the neutrons, lithium isotopes gives an example. Means we cannot use this formula for the halonuclide, which are neutron rich nuclide. Means those atoms which have greater number of neutron, we cannot use this formula to find the radius of that atoms, and for the rest of the atom we can use this formula. R is equal to R naught a power 1 over 3. Okay, so I will stop at this point, and then next I will go ahead and we will discuss the next incoming topics.